explain it, right? What physics should you apply, and how can you make a convincing argument? Remember, guys, one of the most valuable skills you can have is not necessarily knowing physics. I mean, if you're going to be an engineer, if you're going to be a physicist, yeah, you got to know physics. But a more valuable skill than that is being able to make an argument that's convincing. And so, whenever you write a response to something like this, you've got to convince me, the reader, that you're right, that you know what you're talking about. I should read your response, and I should walk away going, aha, yeah, that's it. That's why that happens. I'll buy that. I should walk away really feeling good about your response. And so if you're not feeling like it's rock solid, then I'm not going to think it is either. So let me sketch this out. So you have a disk. And that disk has an axle. And one of the pieces of info in the problem tells us that the axle is frictionless. And so some people were trying to make an argument having to do with the axle rubbing on the disk. It doesn't work because it doesn't matter if the axle rubs on the disk, it's frictionless. This is in mystical, magical, imaginary physics land. It's not in the real world.
Ah, I forgot to share your screen.
I did, sorry. We're in mystical, magical physics land. So you can't use, if I say there's no friction, there's no friction. You can't make an argument that involves friction. And so we're dropping a lump of clay, and it's gonna fall straight down. And then you can imagine in your mind that when this happens, the disk slows. And so the question is, why? Why does the disk slow down? And when I walk away from this, I want to believe it. I want to believe that that's the reason why. What do you think?
It's because whenever the clay drops onto the disc and it sticks, the disc is trying to turn this way, but the clay doesn't really have that rotation at the moment. So it's trying to stay in place. When the disc tries to move and the clay doesn't, they enact like an equal opposite friction force. And if the clay isn't sliding, then it means that the disc is losing speed.
Okay, I think you've got the basic idea here. So splat, the clay goes splat on here. I think you got the idea. Let's look at it from the top down as well as from the side. So I don't remember exactly. I think the disc was rotating in this direction. So then from top down, it's rotating in this direction. Okay, so you talked about a couple of things. You said that the clay isn't rotating, right? So I think that's the first piece that has to be addressed here. The clay is just moving straight down. Before it collides with the disc, does the clay have any horizontal motion at all?
No.
So what does Newton say? If you have no horizontal motion, what has to happen in order for you to gain horizontal motion?
Unbalanced force. An external force.
You have to have a force. Yeah. If there's no horizontal motion, guys, if there's no horizontal motion, there needs to be a horizontal force applied so that you gain that horizontal motion. So there's got to be a horizontal force applied to the clay. Otherwise, it wouldn't gain any horizontal speed. It has vertical velocity. Now, you have to be careful here. What is the force that the disc applies to the clay? Because I saw some people say that it stops the clay from moving down. And that's true. The disc is going to apply an upward force. That's the normal force. But that force won't make the clay move horizontally. That just brings it to a stop vertically.
Friction?
It's friction. There's friction between the clay and the disc. So you've got to mention that. That's important. In your final answer, that's going to matter. That's why I kind of gave it as a hint. What is the role of friction here? Clay is not moving horizontally, and then all of a sudden it is. So a force had to make it do that. The force that made it do that was friction. Otherwise, imagine that there was no friction, right? Then the clay would fall plop on the disc, and then the disc would just spin underneath it, and the clay would just sit there. That would be weird looking, right?
So that's why it sticks.
Yes. So it's sticking because of friction. Okay, so that gets us part of the way, but that's not all the way to the answer. So we've said, okay, so the disc exerts a force on the clay. That's great, but the question didn't ask about what happens to the clay. It asked about why does the disc slow down. So does the disc slow down because there's a force applied to it?
Yes. Yeah.
Yes.
Okay, so, let me ask you guys. Remember, the disk is not moving. The disk isn't moving. What is the disk doing? It's rotating. Do forces cause changes in rotation? I'm going to apply a force to this bottle. Am I causing a change to its rotation? I cause a change to its linear motion. Forces change linear motion. Do forces change rotation? What do you need to change the rotation of an object? You know, torque. Okay, so you got to complete this argument by arguing that there's a torque on the disk. So far, up until now, we've argued that there's a force. That's all well and good, but there's no net force on this disk. The disk doesn't accelerate anywhere. So you now need to argue that there's somehow a torque. How can we argue that there's a torque on the disk? From the clay. What are the two things you need to produce a torque? You need a force.
In a distance.
And it needs to be applied at distance. What is the distance away from? Is this friction force acting at a distance away from the axis of rotation? So let's look, because if the clay speeds up, then it's got to receive a force in that direction. Would you guys agree? So if the clay feels a force in that direction, then Newton says the disk will feel a force in which direction? Opposite direction, equal and opposite forces. So that's force. You don't like my pen? So guys, looking at my diagram here, do you see why that friction force produces a torque on the disk? So you've got to make a complete argument. You can't just toss in a few of the pieces. You can't just mention a few of the main concepts. You've got to give all the parts, and you got to explain how they all tie together. Making a convincing argument isn't always easy to do. Guys, when I read your argument, what I'm looking for is, do you have a clear logical flow? Can I follow your logic, or do I have to jump around? Do I have to rearrange the pieces of your logic in my mind? Because if I have to do that, that's way too much work and I can't do it. There needs to be a clear logical flow from whatever your premises are, which are generally the principles of physics, to your conclusion. Lead me, guide me down the path. Tell me how each step leads to the next. Don't assume that I know anything at all about logic. Lead me along your argument.
Are we also ignoring the mass of the disk?
Are we? How do you mean?
Like, is the question saying that the disk is massless, or is that?
The disk is not massless, but we're not. You would, if I asked you by how much does the disk slow down, then we would have to worry about its mass.
No.
Because you can imagine if this was some super giant concrete wheel, it's not going to slow down much. Versus if it's a little tiny thin, like say, record or a CD, it's going to slow down a lot. Right? So the mass of the disk would matter if we cared by how much. But we're not worried about that. So guys, you can go in and edit your answer. If you feel like you already have it.
Oh my God.
If you feel like